This is the fourth day of Unit 3, Section 1. We are in text section 4.4. So today we're going to talk about factoring. So to factor completely, you're getting to a point that cannot be factored any further. And there's a few things we're going to look at with factor. We're always going to check for a GCF or greatest common factor first. Then we have a bunch of different types. If we have x squared plus bx plus c, so there's a 1 in front or no number in front of the x squared, and then I have a number in front of the x and a constant, we're going to end up rewriting that as two factors, using the two numbers that multiply to whatever c is and add to whatever b is. Then we have some special patterns. That's if there's only two terms. So that's something like x squared or a squared minus b squared, a squared minus b squared, or it could be a cubed minus b cubed, or a cubed plus b cubed. Those are the special patterns we're going to look at. We can also factor with four terms, and to do that, we will try factor by grouping. So that's where we split the four terms into two halves. We take a GCF from each, and then we'll rewrite that as two factors. And then the last one is quadratic form. So we're going to treat that as a regular quadratic, but we're going to divide the first power by 2 to get what really is going to go here. So if it was x to the 6th, this is now x to the 3rd and x to the 3rd. Let's start out with some basic ones. We want to factor these completely. So the first one is of the form a squared minus b squared. And the special pattern for that is a plus b, a minus b. If I look at this, what's being squared in the first spot is x, and what's being squared in the second spot is 7. So that means x and 7 are my a and b, so that's going to be x plus 7, x minus 7. For b, we're looking at what multiplies to c, so multiplies to 144, and is going to add to negative 24. So if I'm adding to a negative, but multiplying to a positive, I'm looking at two negative numbers. So I can look at negative 144 and negative 1, or negative 2 and negative 72, and I can keep going through the list until I actually get to negative 12 and negative 12, because these add to negative 24. So my answer can be written as x minus 12 times x minus 12, or x minus 12 squared. Either answer is fine. For C, I have a 2 in front. But if I look at everything, I actually have a 2 in everything, right? Everything is even, so everything's divisible by 2. So we're going to divide all the terms by 2 and put that number on the outside. So we're left with x squared minus 2x minus 8. And now this becomes a problem like this. We're going to multiply to negative 8 and add to negative 2. So now we're multiplying to a negative, so one's positive, one's negative. So I could look at negative 1 and 8, or 1 and negative 8. So that's positive 7, negative 7. Neither one is 2. I could look at negative 2 and 4, or 2 and negative 4. This is positive 2 when I add them. This is negative 2 when I add them. So these are the numbers I'm going to use. So when I factor this, the 2 is going to still stay on the outside here. And now we're going to have x plus 2 and x minus 4. We'll do some more together. All right, same idea, but they have a little bit more GCF to them. So if I look at A, I notice I have x cubed, x squared, and x. So all three terms have an x in them. So that's actually what I'm going to start by taking out. So now we're left with x squared minus 4x minus 5. So the things that multiply to negative 5 that add to negative 4 are negative 5 and positive 1. So we have x minus 5, x plus 1, right? 5 times 1 is 5. Negative 5 plus positive 1 is negative 4. That's our answer. All right, when I look at B, I have a number in both, right? 3 and 48. So 3 goes into both of those. So I know I'll at least divide by 3. And then I have x to the 5th and x to the 3rd. The smallest number that goes into both would be 3. So that's x to the 3rd we could take out of each. So on this side, The 3 divided by 3 canceled, and x to the third over, x to the fifth over x to the third is x squared. Then negative 48 over 3 is negative 16, and the x to the thirds cancel. Now this is one of those special patterns that we just saw on the previous page. It's a squared minus b squared. So the a that's being squared is x, the b that's being squared is 4, so it's x plus 4, x minus 4. All right, in C, I actually have a 5 that can go into all three of them. And they all have x's, and the lowest power of x is x squared. So we'll be able to take x squared out of each one as well. So we have 5x squared out here. This turns into 1x squared. This turns into 6x, and this turns into 9. So we're looking for things that multiply to 9 that add to 6. So that's our 3 and 3. So that's x plus 3 times x plus 3. And I can also write that as x plus 3 squared. All right, you go ahead and try the next ones, pause it, and I'll show the answer. All right, so go ahead, check those answers. All right, now we're going to get to some more special patterns, and we're going to get to the sum and difference of two cubes. So that's something being cubed plus something being cubed, or something being cubed minus something being cubed. So the way it's going to factor is we're going to figure out what's being cubed in each position. So we may have to take the cube root on our calculator, and then we're going to take whatever was in this spot plus whatever was in this spot for the first part, then whatever was here squared minus their product plus whatever was here squared. And then if it's a difference, if it's a minus, we start with a minus and then the other two signs are positive. So either way, we have one minus sign overall, right? A positive starts with positive, a negative starts with negative. So if we're going to factor these completely, our first thing is to look at what's being cubed in each position. So in this position, it's an x that's being cubed. And in this position, we have to take the cube root of 125. So if we take the cube root of 125, we get 5. So plugging this into the pattern, let's rewrite the pattern up here. For minus, it was a minus b, a squared plus ab plus b squared. So that means we're going to put x minus 5 is the first thing, and then x squared plus 5 times x plus 5 squared, which is 25. Right, and that's our answer. This is the pattern because this cannot be factored any further. If I look at B, again, I have a positive x that's being cubed in the first spot, and the cube root of 64 is 4. So the only thing that's different about the pattern now is this is a plus and this is a minus. So we're going to get x plus 4 first, x squared minus 4 times x plus 4 squared is 16. Okay. And our last one here, 16 and 54 are not perfect cubes. X to the fifth and x squared are not perfect cubes. So we're going to start by taking out a GCF. They're both even, so I could take out 2. And the lowest power of x I can look at is x squared, so we'll take out 2x squared. So now we have 2x squared on the outside. Then we have 8x to the third plus 27. So this term is really 2x that's being cubed, and this term is really 3 that's being cubed. So I'm going to bring down my GCF, and now I have the plus pattern, 2x plus 3, 2x squared, so 2 times 2 is 4, x times x is x squared, minus 2x times 3, so minus 6x, plus 3 times 3, or 9. Right, and there's our answer for that one. You go ahead and try these two, pause it, and I'll show the answers. All right, so check your answers there. In 4, it was x being cubed and 8 being cubed. For 5, we had a GCF of 2x squared, so then I was left with 8x cubed, which is 2x being cubed, and 125, which is 5 being, 5 being cubed. All right, our next one has 4 terms to it. So whenever we have 4 terms, our first attempt should be to factor it by grouping. And it's called grouping because we're actually going to group it into 2 parts. Right, the first 2 terms and the last 2 terms. For the first 2 terms, I have an x squared in them. So I'm going to factor out x squared, and I'm left then with x here plus 5. In the second 2 terms, I'm looking for their own GCF, and they both have a negative, so I'm going to take out negative, and they both have 4, so I'm going to take out negative 4. So now when I divide this by negative 4, I get x, and when I divide negative 20 by negative 4, I get plus 5. If this worked correctly, this term should match this term. And if it does, I can rewrite it as that matching term as one factor, and then the leftovers make the other factor. All right, I would be done, except this actually can go further, and because it says factor completely, we have to go as far as we can. So this is a squared minus b squared, which we remember is a plus b, a minus b. So I can rewrite my final answer as x plus 5, and then x plus 2, x minus 2. You go ahead and try the next one, pause, and I'll show the answer. All right, so there's our answer for that one. And the last kind we're going to look at is the quadratic form. And it's called quadratic form because it follows all the rules of normal quadratic factoring, except it's not quadratic. There's higher powers. So in this, there is no GCF. There's no x term to take out here. And this is 16, which is only divisible by 2, 4, 8, and 1 and 16. And this is 81, which is only divisible by 1, 3, 27, 9. So they don't have any common factors. But this is really 4x squared being squared. And this is really 9 being squared. So this is actually the difference of 2 perfect squares. Again, a plus b, a minus b. So that's going to be 4x squared plus 9 and 4x squared minus 9. Be careful here. This is another difference of 2 perfect squares, 2x being squared and 3 being squared. So our final answer is actually going to be 2x plus 3 and 2x minus 3 times the original 4x squared plus 9. All right, in part B, I definitely have a GCF in here, right? I can at least take out x squared and I could take out 3 from everything. So if I took out or divided out 3x squared, 3 over 3 is 1, x to the 8th over x squared is x to the 6th, 15 over 3 is 5, x to the 5th over x squared is x to the 3rd, and then 18 over 3 is 6, x squared over x squared cancel. So even though this doesn't look like a quadratic, it is of the same form because it's something being squared here, plus 5 times half of that, right? This power is half of this one, so that works, plus a constant. So I'm going to look at it as what multiplies to 6 and adds to 5, right? We could do 6 and 1, we can do 3 and 2. And 3 and 2 does in fact add to 5. So when we write our answer, instead of writing x squared, or sorry, x plus 3 and x plus 2, we're going to do x to the 3rd, half of that plus 3, and x to the 3rd, half of that plus 2. So go ahead, try the last ones, pause, and I'll show the answers. All right, there are your answers, and that is the end of 4-4 day 1.